Okay, if you're like me, you're probably tired of the NSA reading all your text messages. So one clever and easy way of avoiding that, they'll never figure it out, is to use a Cipher cipher. So say I have a message that says, "Hi, Dr. Glauer." If I was to shift each letter over by one, the message would then translate into IJAESAHMPXFS. Completely incoherent, and they probably won't figure it out. So you're probably saying to yourself, wow, this is great, Jacob. I can now encode "Hi, Dr. Glauer," and the NSA will not be able to read my text message. But that's kind of a lot of work. I have to shift over every single letter by an arbitrary key. Well, I'm here for you. I've created an embedded system that can encode any 16-bit message using the Cipher cipher. Here, let me show you how it works. Okay, that actually takes a fair bit of time to type out, but as you can see, we now have a message, "Hi, Dr. Glauer." If we press RB0 right here, it will then prompt us for a key. Let's say we want our key to be 5. Okay, we enter 5, press RB0 again, and then it prompts, I can hit any key to encrypt the message. Let's do that. Alright, so now we have MNEIWELQTAJW. Wow, I have no idea. Okay, so our algorithm has provided us with a NSA-proof string, and also provided a decryption key as well. So after you send this over an arbitrary unencrypted line, your correspondent can take this string, enter it into the algorithm, type in the decryption code, and decrypt it. Wow. Hi, Dr. Glauer. Amazing. Okay, for the code walkthrough, we're actually going to keep it fairly high level. There's a lot of functions that are literally just figuring out how to parse strings and displaying the string on the display, and that's not really what this project is about. It's mostly about getting input from a keypad and encrypting that message that you input using a Cipher cipher. So I'll just quickly walk through the other functions and then we'll get to that. First one is wait. It just waits an arbitrary amount of time. I believe it's 1 millisecond. LCD write number. This writes a number to the LCD display. Write character writes character to the LCD display. Write string writes a string to the LCD display, which is just an array of characters. Get key is a modified version of the get key from Dr. Glauer. It basically just watches port C for input to the keypad and encodes that into numbers like 1, 4, 7, 10, etc. It also watches port B for additional input, not on the keypad but on the push buttons. Read key just reads in the key and debounces the input, so we're not getting a ton of key presses for one key press. Courtesy of Mark Olberding, because I am not quite as familiar with pointers as he is, so thanks for his help. I have this lovely program called function called writeString that just takes an array of characters and writes the entire thing to the LCD display. Empty string generates an empty string, believe it or not. Yeah, that's about all there is to that one. Nullify is kind of a fun one. It it takes it in an input string and then fills it with null characters, which is really useful if you're using this function writeString, because it writes until either it hits 16 characters, which is the size of the the amount of characters in a row of the LCD display, or until it hits a null character. Let's see here. Read encoded string. This is where a lot of the magic happens regarding input from the keypad. What I ended up doing in order to represent all of the letters of the alphabet with a keypad that only contains 12 digits is, for the digits 1 through 9, I assigned each one a letter, 3 letters. So for instance, 1 would be ABC, 2 would be D, E, F, etc., etc. In order to cycle through that, you just press 1 the number of times that you want, the number of times that represents the character. So like, if I wanted the letter A, I'd press 1 once. If I wanted the letter B, I'd press it twice. C, I'd press it 3 times. If I mess up, no big deal. It'll just rotate back around and go back to A. So yeah, that's mostly what this function does. It also includes a way of creating a space by just shifting the character on over using the hashtag, or shifting back or deleting previous characters using the star. For array to number, when you're entering the key, it'll actually be read in as a string, and so we have to decode that string into number, and so that's what this function does. Read passkey, oops, we're going to pretend that wasn't there. Read passkey reads in the passkey for the Cipher cipher, and so it basically just once again reads in a string, same as this function, and then it uses the array to number function to turn that string into an unsigned integer. Encrypt is where the Cipher cipher actually happens. As you can see, the majority of the code is just dealing with strings, which is kind of ridiculous, and actually what the majority of the time spent on the assignment was doing was figuring out how to deal with all these strings. The Cipher cipher itself is very, very simple to implement. You just basically have a for loop, or in my case a while loop, and you shift the letters over the number of times that's in the key. It's a little bit more complicated because there's I decided to include the space key in the space character in my encoding, so there's a few conditionals that deal with that. Initialize just initializes all the ports of the pick, and this is our main function, which just first of all clears the LCD display, calls a read message function, which will read in your 16 character message that you want encrypted, reads in the key using the read passkey function, displays on the display, hit any key to encrypt, just to kind of let the user know what's going on. It reads in and it waits until you hit any key, which is what the read key does. It just waits until you hit a key. And then it encrypts the message using the message it's retrieved and the key that it's retrieved, writes that message on the display, and then writes the corresponding decryption key on the display. And if you want to decrypt something, you just enter the encrypted string on the display, and then you re-encrypt it with the decryption key, because this algorithm is very symmetric, and so you can just to decrypt something, you just re-encrypt it with the corresponding decryption key. And this is a nice little flow chart that kind of sees what happens. And the code should be available on GitHub if you'd like to know more.